Hi there, welcome back. Today we're going to talk about relays. Small relays like this and how to use them, and certainly not oh my god, certainly how not to use them. Because this is one of the things that could cause a lot of electrocution, etc, etc, because people are using these to switch mains voltage. By mains voltage I mean things that are coming out of your plugs. Unless you are a certified electrician or really know what you're doing and are authorized to do so, you shouldn't be installing these on mains voltage, even though it says it's safe. Don't believe it. Sure, this might be safe, but if you're connecting it wrong, it might not be safe. And I'm sure I'm going to mention it a few more times today because it's really dangerous. I see a lot of videos on YouTube where young people are switching a lamp on and off using this exactly device. And it's terrible. Of course, I write to them in the comment section and tell them not to, and they call me a arrogant fuck. So, sure. Your choice, don't tell me I didn't warn you. But what we can do with this, without being an electrician or without having the proper education, is we can use this to switch small water pumps, things like this, a small motor, and control LEDs, even things like that LED light over there. Sure, that's fine because we are running on a low voltage, or it's actually called ultra low because we are running less than 48 volts, and we are not even, well, that thing over there, it might be running maybe maximum 2 amps. 2 amps, that's dangerous. It takes 0.02 to kill a person, so that's actually quite dangerous. But I know that thing is only running on 12 volts, so no problem. Just be careful, that's all I'm saying. Okay, let's see how we're going to use these, or how they work. So, here we go. This is the small relay, and we have 3 wires coming off it and a short circuit down here between common and ground. And it's easy to use these modern relays. Previously, when you went into an electronic store and bought a relay, you will just get this blue box and it will have 5 legs or something below. You can see 1, 2, 3, 4, 5, and you would, well, how am I going to use that? Well, luckily people has made it easy for us now, and we can just buy these components as is, and they even include a optocoupler. That's this little black box right there. It's very important. We don't even need to know how these pins are connected, but it's still nice to know that when you look at this, you can see it's just like on chips. It has a round marking for pin number 1, so pin number 1 is this one, and you can see it goes up to power VCC. And then we have number 2, that's the big line in the middle, goes right here, that's the one called common. And we have number 3, that's ground. You can see it goes up here, there's some current resist limiting on. Then we have number 4 over here, that's normally closed. I'll show you in a minute what that means. And the last one down here, it's normally open, that's over here, and we'll also talk about that. But before that, let's talk about limitations of this device, because I see a lot of people on the internet using these to actually switch main voltages. Don't do that. Even though this claims to be rated for mains voltage, you can see it says 10 amps at 250 volts AC, or 10 amps at 125 volts AC. Why both? That's a bit strange. Anyway, 10 amps at 30 volts DC, 10 amps at 28 volts DC. Why these for? Anyway, It's a good device. It's a perfectly fine device. Don't be worried about that, but don't go up near these limitations. Don't start switching your lamps and stuff like that with this device. Sure, it can handle it for a while, but the risk of failure is so great when you're using device just running on the edge. Plus, it's only one pole. If you're going to switch main alternating current, 2 wires, and you're only switching one of them, there's a live and a neutral. Do you know which one is which? Let's just say I'm putting the neutral in normally open, meaning this is how it goes. My finger is the live, this is neutral, so I got power coming in here up to a lamp up here, but my ground is disconnected, or my neutral, sorry. What would happen if you were to touch the metal or some live part up here and maybe touch the radiator at the same time, or another grounded thing? Take a wild guess. If you're going to switch alternating current, you need 2 poles at least. You need one for each wire. I don't care who you are, what you know, you need to switch. If you're buying house regulated devices, they look like this. There's a big difference. This is for 3 poles, so that's even more, but that's 400 volts. Doesn't matter. There's a reason why things have this different size. Okay, it's not just cosmetic. it's for your own safety. So, but we are working with low voltage, so we are using this to switch maybe up to 50 volts, and we are never going up at 10 amps, maybe 1 amp at the most on these wires. Okay, well, let's go over the device. So we have our connectors out here which are connecting the higher current, and back here we have the low control current. So basically, if you separate the device right here, on the right side we have control systems, and on the left side we are switching something higher than our control system. So we are using maybe 3 volts over here and 30 volts over here. This device is extra smart because it has a optocoupler. That's the black box right there. It makes a physical separation of these two, and that's very impressive. Well, it's impressive that they include it on a device like this, and that's a form of security. The relay itself doesn't really have the same separation as this does, so you're actually physically separating the 2 lines down the middle here. I'll show you in a minute on a drawing. I have just connected 3 wires to this. The brown is connected to the pin called IN. It's the middle one, as we can tell on this one. There we go. You can see it goes over here. And VCC is of course 5 volts. In this case, you can also run these on 3 volts. It doesn't require that much. And that's because of the optocoupler. Amazing. And we got ground. So, how does this work? Well, pen and paper, role-playing game. We have our device. So, let's turn it... No, let's keep it this way. So, let's just go over it from the left to the right. First of all, we have power coming in. And this is our switching pin, the one called IN. It goes into the optocoupler. We're going to skip the resistors, and all this is just resistors and LEDs to indicate if the power is on, etc. It even has a small, let's see, yeah, linear transformer right there, voltage regulator to 3.3 volts. Ignore that for now. We're just going over the rough part. Line goes in. We have the optocoupler first. So optocoupler, that's the black box right there. It's very hard to see, yeah. It goes in here, and then we have possibly ground like that. Inside this box we have a LED, we have a resistor. The LED emits light when we send power through the IN. When the light emits, a photo sensor, it's basically a resistor, reacts to that and enables connection between these two pins. So you can see it matches perfectly. It has 2 down here and 2 up here. So the nice part about this is there is no physical connection between the left and the right side. We're just using light, and this is a good way to separate. But the problem is the distance. This distance between these 2 lines, let's call them delta D. This distance needs to be greater than the voltage you're going to supply through here, because voltage will creep along the edges of plastic and stuff like this. So that is why you make separation in here, so it doesn't creep. But you have a couple of spots where your common is too close. I'm sure it's fine, but I still don't want to trust it with 220 volts. Anyway, that was the optocoupler. Now we have the relay itself inside the relay. So we have 2 pins coming in. Yeah, we have some ground. This is still ground. It's going to be grounded over here. Inside the relay we have a inductor. So let's draw a box. It's the big blue. There we go. A inductor is basically, when you power it, it's going to generate a magnetic field. That magnetic field is going to switch a pin. So what we have is, we're going to draw it exactly like it's here. So we have 3 pins out. Inside we have 1 like this, 1 like this, and I do believe it looks like this inside, really. Oh, that's ugly. Let's do this up here. So we have our inductor, something like that, and this is the same. So we got power coming in here. We have the pins. I think it's reversed. This one is called NC for normally closed, and this one is called NO for normally opened. So how do we identify these? Well, and this one is common. Common is the pin in the middle. It's going to stand like this or this. It's basically a flip switch. And when it's flipped on this side, it's connecting to the top. That's this one. And when it's flipped to this side, it's connecting to the bottom. That's this one. However, by default, when not powered, it shows on the drawing that it's connected to the top one. That's this one. So it's called a normally closed. If I wanted to work this just like a regular switch, by default, when not powered, I would expect it to be off. Then I would use this one. Connect my wires between this one and this one up here. If I wanted the power to be constant running through this device, when not powered, then I would connect between the 2 top ones. Might be difficult to understand. Let's build something and test it out. So we got our device. I'm using a Arduino as a power source. Yep, there we go. And I got a breadboard with a LED and a resistor. Nothing else. Got some wires. Wires, more wires. Okay, so what do we want to happen? Well, I want this to be off by default, and whenever I power this thing, I want it to turn on. Okay, so by that reasoning, I need to use the normally open connection. Normally open means the power is not able to run through it. So I need to use these 2 terminals up here. So let's put a wire in And then let's loosen this up a bit. There we go. Wire in and in the middle, and just fasten them a bit, just a little bit. There we go. There's a small speaker on this device. It's really annoying. So, as you can see, I'm only using 2 of the ports. I'm not going to use the 3rd. And the way we're going to work this is we imagine a separate power coming in through the middle. So power is going into the middle, and eventually it should go out to the LED. But not by default, only when we tell it to. Oh, alright, that's silly. Shouldn't throw it away when I want to use it. So I'm just going to power the top rail with the Arduino's 5 volts. Well, maybe we should use another one, because this one is about to blow up. It has a short circuit or something. So, Arduino. Yes, new one. Here we go. And let's get some power. There we go. Much better. Again, I'm going to power the top rail up here. 5 volts. There we go. And I'm going to power or ground this rail over here. Ground. There we go. Now we have connection to the board, but the LED is still not on. Perfect. Next thing I want is to hook this up to my Arduino. So let's get a black wire here to ground. Common ground. Get a orange wire for power. Connected also to the 5 volts bar. And we got a red indicator over here. This indicator just means it's powered right now. But as you can see, the light is still not on, because we need to power the controller. Now the yellow line is going to symbolize us connecting to the Arduino or something else, and actually just turning the switch on and off. So whenever I connect this to power, the light should turn on. It worked. There's also an indicator here indicating that the power is running through the device right now and the light is on. That's a relay. Let's try something else. Let's say I got my Arduino sketch loaded up on screen, which you can't see, and I'm going to upload the Blink program to the Arduino right now, and it's uploading. We should see the indicator lights right here start flashing any minute now. These two. There we go. And we can see pin 13 is blinking, so let's try hooking it there. There we go. That's a relay in function, and it's running as expected. You can also get, sorry about that, an array of relays like this. It's the same thing. I just have 8 of these, except they are lower rated. These are just for 3 amps and this is for 10 amps, they claim. Got a power and a ground, and the rest of these is working just like the yellow one, so I'm just able to switch one of them on and off each separately. What can be a problem is when using a device like this, a normal Arduino is not able to power them all on the 5 volt wire. It's not able to put enough amps into this. But a battery pack like this will be able to power this just fine. As a matter of fact, let's see if we connect power. There we go. It's let's see, that's sorry about that. Right now we have 1.5, that's 3, that's 6 volts maximum. I think the batteries I have done anyway. So in theory, if I were to hook any one of these up to my pin 13, it would now switch that. So we're just going to pick a random and stick it into my pin 13. Or at least I thought. Well, you know what the problem is? There's no common ground. It has no reference, so it won't work. In order to make this work, you need to share a common ground with the device. I don't think I can fit. Oh yeah, we could. Yeah. You have to be very careful when doing stuff like I'm doing right now, because right now I'm actually putting a higher potential, negative potential on the Arduino. There we go. It has a different sound because it's a different device. But any of these just switching. And if we want to try something fun, why don't we hook them all up to the same line? Just to see if the battery pack is able to switch all of them at the same time. Sort of a stress test if you want. So there we go. And let's just hook pin 13 up to all of them over there. Perfectly. And when you're holding it like this, you can really feel the solenoids switching. It's actually just the arm switching back and forth like that between all of these at the same time. And that's basically how a relay works. Well, that was fun. Worked like a charm, etc, etc. For those interested, the Arduino is fine. I just checked it. I think I short-circuited it when I dropped my screwdriver on it, and it made that sound. Just gave it a few minutes of rest, and the noise is gone again. What caused the noise, I'm not sure, but I would guess maybe a capacitor or something like that. It's fine. It's working again, and the noise is gone. Well, we had fun with relays, both a series of 8 and a single, and we now have an idea how to hook these up and how to use them, and certainly how not to use them. Enough with that. I actually use one of these in real life in my greenhouse down there on the field, where I switched a water pump using one of these. It's only a 12-volt water pump, and it's running on a car battery. Works fine. And a Arduino is actually switching the pump on and off when required. That's one purpose for these. You can also use them as a security, where you actually have a button that needs to be pressed or flip switch before it's possible to allow current to run through. And this can be triggered remotely over long distances, and that's why this is useful, because otherwise you could just have a button right where this sits, okay? But this can be triggered electronically. Very clever. So, nice little device, but you've got to be careful. That's all I'm saying. Be careful when using these. And that's it for today. I'll see you next time. Bye.